what I want to do is just give you a little overview on what I've been working on. So I've been working with Matt's group and SCME for a while, and I think one of the reasons that Matt reached out to us, and I'm a director of a biotech program in Texas, and I think Jared had mentioned earlier about maybe diversifying some of the curricula in this group towards the life sciences. I think that the physical sciences and engineering kind of dominate this group, and one opportunity that might be of interest to some would be to partner with programs like biotech programs to kind of move into the life science areas. And the way I've always looked at this is a lot of the curricula that I see is on the fabrication side, but from the biotechnician point of view, at least, and probably some others as well, the user point of view would be very, very useful. I know I was interested in getting involved with this group because of the MEMS, the focus on micro and nanotechnology devices that are used in biotech. And not so much our students don't necessarily need to know how to fabricate the instruments, but by having deep insights into how these instruments operate, kind of pulling back the curtain, if you will, it really does help them with troubleshooting, which is one of the main skill sets that they need to be successful in our industry. So what we've decided to do in addition to what we had originally agreed to do, which was to bring some of the SCME pre-existing curricula into our program, which we've done, an early on idea that we had was to develop a kit. Now, SCME, many of you probably know, have developed some hands-on classroom kits that simulate some technologies that are usually out of reach for community colleges, high schools, at least at their own locations. And so certainly no different here. So with the SCME kits, I think they only have at the time we entered one life science oriented one. It's on microarrays, which is great, but there's certainly many other MEMS technologies that are life science oriented. And one that was of particular interest to us was a collection of technologies centered on DNA sequencing, because that's such a major technology that's aligned with biotechnology. So there's some challenges to teaching DNA sequencing in biotech curricula. One of them is that it's not one technology. There are many technologies. In fact, what this poster sort of shows and what the kit that we're developing will show is that depending on how you define it, you can call it 4 generations of technology. All of them are still relevant in various ways even today. And so it's challenging because there's so many different technologies that fall under the DNA sequencing umbrella. And these are all very complex technologies, so it can be challenging for especially beginning students to comprehend. There's so many of them is another challenge, and they're also very expensive, most of them at least. So students don't have a lot of access. So anyway, what we decided to do was, and now it's a slow process when you do it this way, but we really felt that it was important that the development of the kit would not only be something that would be useful once it was finished, but it could be useful to teaching while we were actually developing it. And what I did was I handed off a lot of the actual development tasks to the students themselves, biotech students themselves. So we've been working on this for a few years now, a couple years now, and I've spread the wealth into various classes. So what the poster basically shows, and I won't walk you through in excruciating detail, but basically what we've used this as is an excuse to teach DNA sequencing to a number of different students at a number of different levels. And what I have featured here on the poster is 3 different classes that we involved with this process. We have our Introduction to Biotech class. That first image there that you can see, student holding up a poster, I think I can point to it, this was our introductory class. These are beginning students. And what we did here was we gave some basic knowledge of technologies that correspond to each of the 4 generations of sequencing technologies, gave them just the basics. And what they did was they came up with just conceptual ideas. So in a prototyping point of view, they were doing the prototype sketches. So what would a kit look like that would explain these techniques? And there we in that picture is a student that is explaining what's called nanopore sequencing technology to his group. And then we also took it to the next class, which was our biotech methods, which is second in our series. And what the biotech methods students did was they took the information that was developed by the intro to biotech students, and they developed documentation on what the kits might look like. So they did things like pre-tests, post-tests. They developed some background materials, some basic illustrations and things like that. Essentially the manuals that would go into the test. And it looks like my time is about to come up, and I'll just wrap up with what we have here is our molecular biology techniques students. They actually started doing some early prototyping. So what we have here just real quickly is this is what's called Sanger sequencing. This is first generation sequencing, Illumina sequencing, which is an example of second very, very important technology in today's world. This is Nanopore, or this is Nanopore. We have two different versions of Nanopore, and a very, very cutting edge technology, something called in situ sequencing, where you can do sequencing even inside a cell. So this is just a taste, but what this is basically a snapshot of our progress so far, and just wanted to focus on the fact that we're involving students in the development of these kits. We should have, I think, our early prototype ready to go in next semester or two.